Nikos, the floor is yours.
Okay, thank you, Tanya. Let me share my slides. Okay, I guess that you can see my slides now in full screen.
Yes, we can. Yes.
Okay, thank you. So my name is Nikos Kalatzis. I work as a technical manager in Neuropublic. My background is more on ICT and designing software. But in Neuropublic, we have a lot of experience on agricultural solutions, and we are interacting a lot with farmers and farmers associations, and working with different type of technologies. So our role here in QuantiFarm project, but also in this academy workshop, is to focus on the interface, let's say, of whatever we saw until now from the QuantiFarm project, which is the QuantiFarm Toolkit. So the next minutes, I'm going to present a number of slides, and also we will browse together the live version of the QuantiFarm Toolkit. We will try to explain why it is needed and how it is renders and visualizes all the information and the rationale that was presented from Caroline and George and Dionysis. And then we're going to elaborate on the toolkit structure, the different pages that it contains, the different tools, and where its tool is focusing. And as I said before, we're going to see some key examples on how to use it. So with regards to this module of this academy, the main objective is to become more familiar with the toolkit's objectives, to familiarize and how to interact with it, to navigate through the online environment, and to try to integrate the toolkit in the decision-making process, which is the most important thing here, of an advisor. How the toolkit can assist an advisor on enriching the amount of information that he or she has in order to make a decision tailored to the context of its customer, of the farm that he tries to support, or the farmers association. So this is, in a sense, what the QuantiFarm Toolkit is trying to do, is trying to assist the decision-making process of the farmer or the advisor. So why we believe that the toolkit is offering something that is somehow unique. This is also connected with the objectives of the QuantiFarm project, which is to promote the use of DATS in digital agricultural technological solutions in the European Union, but by providing tangible potential benefits. The main uniqueness, let's say, of the approach is that the evaluation of the performance of the DATS is independent. This means that QuantiFarm is not associated with any kind of company or provider of the digital solutions, and it also involves all the experts that are able to define a methodological framework for assessing the performance of the DATS. It also, as it was described in the beginning of this project, we have 3 years for evaluating the performance of the DATS in different contexts. So this creates a lot of knowledge with regards to the performance of the different technologies, and what we try to do through the toolkit is to render this information to everyone in an easy to comprehend way, but also to act as a point of reference in case that you want to elaborate further. As you will see, we have all the reports from the analysis of the assessment of the DATS in the test cases. The full report will be available, but also a short version of the outcomes is easier to comprehend is also available. So these are the objectives of the toolkit, and we are going to present through this toolkit the assessment results of the DATS for each test case in each country for focusing in different crop types. We are trying to do this in a user-friendly way, and also to provide search and filtering functionalities, given that the information might be overwhelming. And yes, and to I also need to mention here that we are targeting different type of users, farmers, advisors, and policymakers, by giving to them different ways of accessing this information. So, as I said before, we have in our consortium the capacity and the expertise to set up a robust methodology for assessing the performance of the DATS. This is a drive driven by Politecnico di Milano, but also from Agricultural University of Athens. What we have done is that we have code the assessment framework as software. So this also allows to automate the process, but also everything is open and public. So both the methodological framework and the code, the implementation code of the software are available openly, and anyone can review it. And as I said before, the assessment of the outcomes, the assessment outcomes for each test case from the DATS are available through the toolkit. And no, sorry. And one of the objectives and the obligations of the QuantiFarm project is to make the toolkit available even after the end of the QuantiFarm project. Now, this is an illustration of how the toolkit is the architecture of the toolkit. The flow of information starts from the left and goes to the right. So what we have done is that we are targeting in different data sources. Our key data sources are the outcomes from the test cases. So we have 30 test cases assessing more than 30 technologies, because in some test cases we have more than one technology used in combination. Then we are also integrating with existing platforms and inventories of digital agricultural technologies. So QuantiFarm is not the first project that makes the attempt to create an inventory of technologies. What is the uniqueness, as I said before, here is that we are also assessing some of these technologies. So interesting and valuable initiatives from, again, funded by the European Commission are Smart Akis and Fair Share, which already contain a list of technologies. And we are also integrating data from other sources, like open sources, like satellite data from Eurostat, etc. What we have done then is that we harmonize this data through connectors or interoperability mechanisms, as we say, and we made them available in a common data repository where we are able to process the collected data, create the outcomes that are targeted, and feed different tools that are trying to address the needs of different categories of users. I'm going to elaborate in all this in the next slides. So as I said before, everything is openly available. If your technical partners are willing to review the way that everything is implemented, you can forward them this source where we have the code of the toolkit and the different tools and the methodologies for integrating the data. And of course, for each different tool, we provide all the necessary documentation on how this is designed and implemented, but also on how to use it. Going a little more into the different data sources that we are integrating, as I said before, we have three main categories. The first one are the test cases. So as you might already be aware, we have 30 test cases in different locations targeting different agricultural activities. It is on purpose, we tried on purpose during the design of the QuantiFarm project to cover all the different regions of Europe and different type of cultivation to an extent that is feasible to do that. So you can see that we have pilots in Cyprus, but also in Finland, in Spain, Portugal, but also in Turkey. So trying to have a wide coverage. The assessment is taking place already for 2 years, 2023 and 2024, and we have 1 more year. We consider that assessing the outcomes of the agricultural production it will be more safe to drive results, to extract results if we go for 3 years, given the changes in weather conditions, and you might have a bad year, and the next year the crops might be better. So having 3 years, we feel that it's safer. The outcomes, we try to make the outcomes as easy to comprehend as possible. We are really interested to identify the monetary equivalent of the performance of the DATs. So you will see a lot of reduced cost or increased costs with different colors, and how this is calculated per hectare. As I said before, the Smart Akis and Fair Share, there are 2 inventories that we are integrating. What we have done is that we have built some kind of mechanisms that we are able to plug into the databases. Of course, this is in cooperation with the different projects and the administrators from the Fair Share inventory, for example. So any kind of updates, any kind of new technologies that are registered in the Fair Share inventory are also replicated to the QuantiFarm inventory. I recommend to also visit Fair Share, as you see here, the address, because a lot of useful information is also available here. The same happened with the Smart Akis inventory, although Smart Akis is not anymore available, but all the knowledge and legacy is included in QuantiFarm. Now, with regards to the data sources that are relevant with open data repositories, we are integrating data products from satellites. As you will see, it's useful for us in the policy monitoring tool to have regional data on, for example, crop types or changes in the weather patterns in order to assist decision making on a regional basis. Also, we are integrating outcomes from Eurostat, given that, again, for the policy monitoring tool, we would like to benchmark and compare with the indicators that are set or are already calculated from previous years from organizations like this, like Eurostat, and also indicators relevant with the Common Agricultural Policy. Now, about the actual toolkit and how it is structured, it's like an easy-to-use web page where we have a horizontal menu with the key information items like home, toolkit, test cases, and contacts. It's available. You can already click in this link and visit the toolkit. I need to stress here that the toolkit is, this is the first release of the toolkit, and we are working in the background. We are going to have a new release at the end of this year or early next year. So January 2025, the toolkit will be updated. It will include also outcomes from the assessment results from the cultivation period, from this cultivation period, but also we are going to restructure look and feel and the sophistication of the tools. The more data we collect, the more sophisticated the tools are becoming. And here some things might seem simple, but we do have the background and the framework to make it more helpful, as I said before, in the next 2 months. Going now into its tool. As I said before, the tools are somehow targeting different types of users. The recommendation tool is one of the main interfaces of toolkit, of the QuantiFarm Toolkit, to the farmers and the advisors. The objective here is that the user is providing a number of properties, of characteristics that he or she would like to see recommendations of relevant DATs. This means that an easy example is that I am a farmer from South Spain, Murcia, and I would like to find a digital agricultural solution that will assist me on optimizing the irrigation. So the user is going to provide information about the sector, like orchards and olive production, and the relevant functionality that I want to see by the DATs, like irrigation management, the benefits that wants to get, something like optimization of irrigation, what language or cost might be associated with these technologies. What the recommendation engine should do is that it will search first if results from a test case from the QuantiFarm project are available, because we consider this as the most tangible evidence on the performance of the DATs. If we don't have a test case that is exactly matches these properties, then a similarity mechanism is working, and the most similar, let's say, outcome to the context of what the user is provided will be recommended, or a list of recommendations. So one of the replies that the farmer might get is the outcomes from the use of DATs for irrigation from South Italy or from South Greece, given the similarity of the climate. As I said, we are going to include in this next release also behavioral aspects in line with what Caroline presented in the first presentation. And already we have a first set of functionalities introduced, included in the current version of the recommendation tool, and that we are going to demonstrate in the next slides. The next tool is the cost-benefit calculator. Again, it targets farmers and advisors. Here, this tool is based on the work that George Papadopoulos presented in the previous presentation. So we have an analysis of about 100 digital agricultural technologies and their properties with regards to the initial cost and the benefits that these tools may provide through their operation. Here, the user selects the category of the crop activities or livestock activities. Selects also the technology, provides some kind of properties of the size of the farm, the investment cost, the number of the years that is planned to use the technology, and the tool provides a set of cost and benefit indicators that potentially the will be reached through the use of this technology. The benchmarking tool, again, targets farmers and advisors. Here, the objective is to provide an online digital farm calendar, meaning that even if an advisor or a farmer is not currently using a farm management information system or any other kind of digital technology for recording the everyday practices like irrigation, plant protection, harvest, fertilizations, and things like that. So the farmer or the user in general can draw the parcels that he operates on and start do some kind of record keeping of the different activities. Within this record keeping, we also ask from the user to provide the doses and the quantities of the various inputs used. And based on these quantities, we are calculating a number of performance metrics and indicators, supporting also the comparison of different parcels or different time periods. So for the same parcel, if we have a full farm calendar for 2 cultivation periods, through this tool we can do a comparison of the different metrics for the 2 cultivation cycles. We are also having some functionalities that allow us to integrate, to upload metrics from environmental stations, like if you have a weather station in your area provided by a national network, for example, or if you already maintain a weather station, you can upload your data here, and a number of calculations are feasible to be realized. For example, here we have also an example for the chilling hours, which is related with the crop production of the next year for the orchards, the amount of the aggregation of hours within specific thresholds. Going to the next tool, the Advanced Decision Support tool. This tool is available as a pre-configured Excel sheet that you can download it and contains all the different pages and equations and functions that are supporting the identification of the most appropriate, let's say, digital agricultural technology based on a statistical analysis methodology, which is called strategic fit and analytical hierarchical process. The main objective here and the main issue is that this tool allows the farmer advisor, because it is a more advanced tool, to set what are the most important factors that influence the decision of the technology, and to go through a cycle of comparisons of the different factors and adding weights to these factors. So at the end, the user will have a report with scores on the different technologies and the offerings that they might have. For all tools, I mean, because these are all now, it's a lot of information that might be kind of complicated. For all tools, there is a detailed manual in a PDF format, which is available for download and for further studying on how to use them. And of course, there is also within the toolkit a Q&A page with all the common questions that we receive about the tools and answers to these questions. And of course, there is the support from our experts within the QuantiFarm project. So you can also send an email if you want to, if you have any issues with using it. The QuantiFarm Toolkit about the policy monitoring tool. Here we target the users that they are in the decision-making loop, let's say, of on a regional basis, and on policies and how these policies might be affected by the use of DATs. So what is the rationale here is that for a number of a relatively small number of parcels that we have within a region, and we define as a region here the European Local Administrative Unit. It's called LAU. It's an official way for clustering the regions in European Union. So we divide the agricultural land of different areas in LAUs, and for selected LAUs that we do have evidence from different test cases in parcels located within this unit. We are trying to extrapolate and to create results on a regional basis. That means that if we have, for example, 10 parcels using a specific technology for optimizing irrigation, and we have another 10 parcels that they don't use any kind of technology for irrigation, and we have access to the amount of the water consumed in both categories of parcels, we are able to, as a next step, to identify within the LAU what is the total amount of agricultural land cultivated with the same crop through the use of crop type identification algorithms based on satellite images, and to proceed with an aggregation on a regional level on analyzing scenarios like what if all parcels in the area was using this technology? What will be the outcome? What will be the benefit? And the same for the opposite. What will happen if all agricultural land in the same area for the same type is not using at all any kind of technology? What will be the projection on using irrigation water in this case? We do the same for fertilizers and pesticides, but also we do aggregations for and projections for harvested yields. Okay, now I think we can go a little into the toolkit. So I'm leaving the. I guess that you still can see my screen, correct?
Yes, we can.
Okay, thank you. So as I said before, you go to this page, you can see the landing page. Here some notes. Is that we received a request that what happens with DATs, with technologies that are not part of the QuantiFarm project. This was also a decision from an early stage from the project that we're not trying to commercially promote the DATs that are part of the QuantiFarm project. This is a proposition as a framework for evaluating the DATs. So the QuantiFarm project is open to include DATs that are not already part of the QuantiFarm project, and to include them in terms of assessing their performance, or to also include them in our inventories, in our directories of DATs. So for both cases, and if a DATs provider wants to have the technology within our catalogs, there is a form that it requires a number of key information, key characteristics of the technology, and by submitting this form, we are going to receive all the required input. We will come back to you, and yes, we are going to include the new technology in our inventory. It is for the benefit of the project to be as more complete as possible. I will go now to the test cases here, to the test cases page. So here you can see more details about the 30 test cases we have told you already in these presentations. And you can see also the countries, the responsible partner, and the solutions that they are under evaluation. Okay, of course, this is also available in the form of the map. And with regards to the technologies, okay, I think something. Okay, you can get more information about the technologies also through the inventory. Now, with regards to the results from the testing periods, as I said, as we already said, there are 3 testing periods. We already have data from the first testing period, and we are now in the process of finalizing the outcomes from 2024. This will be soon updated, and then we have 1 more year. For the first testing period, as I said before, you can see the achieved benefits of using this technology. For example, here we have used the GEASENS system, which is a smart farming system from Greece. And as you can see, it did really well with regards to water consumption. So we had a reduction in water consumption that resulted also in monetary benefit, but it didn't go very well with the reduction of fertilizers and pesticides. So this is just to also show that we're not trying to say that everything is perfect with the technologies. Technology is not there to solve any kind of problems in the world. It needs very careful handling and adaptation to the current context of its case. Also, as I said before, we have the full assessment report available for download. So you can download the PDF and read all the details of the pilots about the technology, the cost of the technology, and the benefits experienced from the implementation of the DATS, and how these results were achieved. So this is the same for all different test cases, and we also have a short description of the methodology that was followed for calculating all these results. Here is the page with the frequently asked questions, and now let's go to the toolkit. As I said, we are currently updating the toolkit, so most of the features will be fully functional at the end of this year. So for each tool, we have a page that describes how the tool works. We have a full manual of how to use the tool with directions step by step. And also a link to the source code of the tool. This is the code. If you are not familiar, this is the program that anyone. So this means that anyone can download this tool and install it in another system. About now the actual tool, the recommendation tool. The idea here is that we are browsing through the different technologies that are maintained in our databases. So if, for example, I ask for a recommendation without any criteria, without any filter, I see here, I will get here 531 different DATs. This is the total amount of DATs currently maintained in the database. So I can start asking more detailed questions like I would like DATs only for irrigation, or I would like DATs for plant protection. And in any case, I will get different filters and which can be further filtered by these different properties. And I can also click on the title of the technology and get more information, and also a link that allows to go to the provider of this technology. As I said, this is available for you to play around openly. There's no restrictions on this. I'm going to the cost and benefit calculator. This is an instantiation, let's say, of what George Papadopoulos explained in the previous presentation. So we have two different categories, like we have crop farming systems and livestock farming systems. Under these top categories, we have subcategories of technologies for cattle, pigs, poultry, and smaller ruminants. And again, here, the different crop farming categories. And for each category, there is there are assigned a number of technologies. Again, here you can see more details for each technology, and for the specific technology, we retrieve from our databases the information that is available in either in scientific papers or in the provided by the providers of this technology, of the owners of this technology. So all these numbers are retrieved from their sources, and then the user can provide its own adaptations, like the number of years that it's planned to use this technology, the total area that's going to be used in the farm, and the number of sensors that will be bought, and do a recalculation according to the different parameters that the user is providing here. Now, with regards to the benchmarking tool, here we also provide some example files, how to create a parcel, how to formulate your data that are to be uploaded here. To remind you that the benchmarking tool is the one that acts as an online digital farm calendar. So the first step is to create a parcel. We have an easy-to-use interface where you either draw on a map, so you identify your parcel or the parcel that you are trying to support, you draw the polygon and you click save, or you are just adding here the coordinates. So we have an example parcel here, and for these parcels, we are providing a form, a digital form, where the user is able to add information about the various activities that are taking place, like I mean, the date that the activity took place, the unit of, if it's an irrigation or application of some kind of input, and the amount and the unit should be go here. So besides having a digital farm calendar, which is quite useful, and it's now a mandatory requirement for many operations in the farms, like also for subsidies from Common Agricultural Policy, also for certification audits and things like that. We are also able, having this information here, we are also able to reason on this, and to create what I said before, what I described before, the different okay, the different aggregates and summaries of the data, and also to do the comparisons if we use different two different parcels or time periods from different for the same parcel but for different time periods. The same goes with measurements from weather stations. So we allow the user to upload a data set with weather recordings. Here you see some key items that are recorded in farms, like temperature, humidity, and wind, but we also support precipitation and things like that. And we support the calculation of, as I said before here, of the chilling hours. If we go for, let's see here. Okay, you see now, I mean, what I have done here is that I asked for the my parcel, as we call it, my large parcel, for the data that we had for 1 month here to calculate how many hours the temperature was among the two thresholds, 2 degrees to 7 degrees, and to see whether the required chilling hours have been collected. Okay, the advanced decision support tool is the one that I said before that is available to download it and to use it as an Excel sheet. And moving directly to the policy monitoring tool. Here we still integrate data from our test cases. The idea is that this tool will become more useful as we bring more data in it. Here you see the LAU I described before. This is the actual boundaries of this LAU region. Within this LAU, we have a number of QuantiFarm test cases on cultivating potato. So the outcomes from this is to select the region, and for the selected region, we are aggregating and extracting a number of data products. So here you can see the statistics on what type of land cover we have in this LAU. If it is a crop type, the crop type areas, and some indicators relevant with the common agricultural policies, whether the area is protected under Natura 2000, etc. Now, with regards to the use of inputs, and more specific to the agrochemicals, what we do is that based on the evidence we have for the test case parcels, we are generalizing for the whole region based on the similarity of our parcels, our test case parcels, with the rest of the agricultural land in the region. So based on this, we can see projections on the amounts of the use of fertilizers and pesticides and the different types of them, and the same for irrigation. And we are also working on trying to do the same extrapolations for economic and social parameters. Again, the manual is available here. The source code is available here in order for you to have more information about this and how it operates. I don't know. I think we covered almost everything. Yes, our next key item here for the QuantiFarm Toolkit that will be also available early in the next year is that it will be feasible for the users to provide a number of parameters that we are collecting through our methodology for assessing the DATS, and to automatically calculate the different indicators that you see here in these results. So we are automating all this process that you see now that it is done manually, and it takes quite a lot of time. So this also allows to provide the assessment framework as a reusable tool. Okay, going back to my slides, I think we covered everything here.